Okay, now changing gears a little bit. So we're going to talk about blue hydrogen now. So I think there was some very nice presentations from ThyssenKrupp on their green electrolyzer technology. And today I want to talk to you a little bit about SLB's technology for blue hydrogen, which is from our partners at ZEG. My name is Tim Rembold. I'm the VP of Petrochemicals for SLB New Energy. The New Energy team was developed about 4 years ago to help bring new technologies to help decarbonize industries such as steel, cement, and the petrochemical space. So I want to give you an introduction to the ZEG technology today, and we should have some time at the end for questions if you have it. So the ZEG ICC technology, or zero emission gas with integrated carbon capture technology, is something that we've partnered with our partners at ZEG in Norway to develop. They have over 20 years experience in this technology, and it's a new alternative for, I think, what most people would consider either an SMR or an ATR-based production route for blue hydrogen. So if you look at the hydrogen value chain, I think there's a lot of discussion points of, how are we going to produce it? Is it green? Is it turquoise? Is it blue? Name a color of the rainbow, and we can start talking about how you could produce hydrogen from that technology. SLB right now is currently focused on two applications: a green hydrogen technology with investments in several different electrolyzer manufacturers, and then this blue hydrogen technology, which is what we're bringing from our partners at ZEG. Today we're going to focus on blue hydrogen. We're not going to talk about logistics and applications, though if you'd like to have a discussion, I'll be free after this. So really what we see, what customers want, and what the industry is expecting as they decarbonize their assets, they're looking for different ways to reduce the carbon intensity of hydrogen that they can then use in their application. So if they can have a greener solution to the fossils that they currently use, that's the main issue, and that's the main topic that they're looking at. So you can see steam methane reforming, you're generating about 9 kgs of CO2 for every kg of hydrogen produced. Blue can be a nice range from 1 to 7. Really, that depends on, are you taking a gray plant and converting it into a blue plant, or are you building a blue plant on purpose with more integrated technology for CO2 capture? You then have many different options from green and other ones, but we'll focus on blue today. So the ZEG technology is a Sorption Enhanced Reforming technology. I think one way you can think of it is we're taking a traditional syngas plant and doing almost all the reactions in a fluidized bed converter. So this is a very novel technique where you have the reforming reaction and the CO2 capture happening at the same time. And for the chemists out there, that's very beneficial to the equilibrium reactions that are occurring. And I'll talk a little bit about those reactions on a later slide. What we see with this technology is you've got a very pure hydrogen stream and pure CO2 stream that comes off. So you're not worried about a traditional steam methane reformer where you have flue gas and low concentrations of CO2 that you have to capture. We have a nice high concentration of CO2 that comes off of this in our regenerator. We also see, since we're taking 5, 6, 7 reactors and scrunching those down into 1 or 2 reactors, you see a significant reduction in the capex required to build one of these plants compared to an ATR or an SMR technology. We also have developed a modular design here too to make sure that we've got set 5 ton per day, 50 ton per day, which we'll talk about, that are the different areas that we're working on right now. To make it modularized and reduce costs even further compared to a stick-built unit. So how does a ZEG unit compare to a traditional blue hydrogen scheme? So on the bottom you can see the typical blue hydrogen production process. And this is actually, your standard gray process where you start with a pre-reformer that helps you convert the natural gas into methane. Then you go into your reformer, which is where you're generating the most of your CO2 and, the bulk of your syngas, which is CO and hydrogen. Then you go to your high shift and low shift to convert that CO into more hydrogen, and finally go into a CO absorber. Now the issue with this process is that the CO absorber, you're getting a lot of nice high concentration CO2 that can be easily captured and sequestered, but the flue gas from the reformers is much more difficult to capture and sequester. So it's more of a challenge to look at this. Now, if you look at the ZEG technology, the Sorption Enhanced Reforming technology that we're offering, you can see it's got a lot of benefits. First, you can see the number of units, process units, is much fewer, so that helps with your CapEx. And what happens is that you actually take your natural gas, your steam, you throw that all into the reformer, and you're doing syngas production as well as CO2 capture in that single fluidized bed unit. So again, think of this reformer as somewhat like an FCC unit that you would see at a refinery. The catalyst and sorbent, CO2 adsorbents, are both in the reformer, and I'll explain that on the next slide. And then what you have is, once you've generated hydrogen, very pure, you can then take the sorbent, move it to your regenerator, and that's where the CO2, pure CO2 stream can be released. Then you have a very similar back end that you would expect from a traditional blue or gray hydrogen plant. You'd have a PSA unit to concentrate both the hydrogen and the CO2 streams, so that the hydrogen's ready for use in industry and the CO2 is ready to be pumped into the ground, or it could be utilized, for SAF or other applications. So a little bit of a detailed diagram here. You can see the reformer and regenerator. The regenerator is in the center of this image on your right here. And this is really set up so you can handle both natural gas and biogas. It's also a fluidized bed with a regenerator, right? So you've got fluidized beds in both the reformer and the regenerator. And that really benefits you in terms of your heat transfer, in terms of your reaction and equilibrium mechanisms, so that as soon as you generate hydrogen and you generate CO2, it's captured, which then allows you to help produce even more hydrogen. And essentially what you're doing is you're feeding natural gas and steam into the reformer. That's where your hydrogen is generated. And then what happens is the sorbent is recirculated between the reformer and regenerator. In the regenerator, the sorbent is heated up to high temperatures to release the CO2. And off the regenerator, you get a nice pure CO2 stream. You do a little bit of cleanup of the CO2 and hydrogen through a PSA, and you're ready to go. So just looking at, for the chemists out there, I have to put some chemical reactions. Otherwise, it's like my safety blanket. I don't feel good. So you can see here the equilibrium reactions for steam methane reformer and water gas shift reactions. What we're doing here is we're taking the CO2 out as soon as it's formed with our novel sorbent, and that allows us to produce even more hydrogen. And for those that realize it, you're going to shift everything to the products and not to the reactants in this. As you can see, the reaction, we have a calcium oxide sorbent that's capturing the CO and the CO2, converting to calcium carbonate. And overall, this reaction is actually exothermic. So a little bit different from your standard SMR unit that's highly endothermic, that you have to fire really hard. This is net exothermic. Now, the area that you do have to heat up quite a bit is the regenerator, which is where our calcium oxide sorbent is regenerated. So you're able to fluidize this over to the regenerator, and that's where you can remove the pure CO2 stream. So you heat it up to 800, 900 C, and then you basically evolve the CO2 directly off the sorbent. That sorbent is then fresh and ready to go back into your reformer. So again, very similar to an FCC unit to produce syngas. If you look at the comparison in terms of levelized cost of hydrogen, we see a significant benefit of our ZEG technology compared to a standard ATR at small scale. And even at large scale, we see about a 5% difference as well there. The benefits, as you know, if you've looked into building an ATR unit, you typically have to have a very large air separation unit, which is very, very costly, which is not a requirement of the ZEG technology. And in addition, we're working on optimizing the catalyst and sorbent formulations to get the overall costs even lower, especially on the OpEx side here. So we see a lot of value in, even at the large scale of these units compared to ATR. So this is not just, a paper exercise. I like to be able to actually show you something that's in the ground. This is our 1 ton per day production unit. Demonstration unit that's in Kolsnes, Norway. This is actually being utilized by a customer, CCB Energy Holding. We're currently commissioning this unit. It's very nice, it's very sophisticated. And as you can see, it's right down the road from the Northern Lights CO2 sequestration project If you haven't been to see that, I highly recommend it. It's a very impressive way that they're looking to sequester CO2 off the shore of Norway. But what this is a 1 ton per day unit, a great demonstration scale to show and prove out that the technology works at scale, that the fluidization is working, that the sorbent and catalyst lives are where we want them to be, that the production rates are where we think they're going to be. And we're in the middle of commissioning this. Hopefully for the next meeting, I'll have some data. We can go through how well it's performing. Again, what are the offerings we have? So SLB and our partner ZEG, we're offering really the next of a kind is what we're looking at right now is a 5 ton per day to 50 ton per day unit. And this is really, again, helping to go up that scale ladder, right? You want to go, you don't necessarily want to go from 1 ton per day to 500 tons per day. That's a pretty big leap when it comes to making syngas. And so you'd like to go to 5 to 50 tons per day. And so we're working with customers, several interested already on building this unit and really, bringing this new technology to scale. And then once we have that in place, we do plan on going to even higher 500 ton per day and plus rates. Those would obviously be built to order units. Those would not be modularized. So again, the new motto for SLB with our new energy team is really building a brighter future for a balanced planet. And we think this new blue hydrogen technology is really going to help customers decarbonize their industry. Any questions?
It's an exothermic reaction. Do you recapture the heat?
Yeah, so we have significant, it might not have been shown on there, there's significant heat integration between that, and that's one part, even as the next of a kind, we're looking at even further heat integration there to avoid too much waste heat. Sure.
Do you know yet how many sorbent cycles one load of sorbent?
So we have a lot of lab data, which is, that's, we haven't fully commissioned this yet. So we think it's going to be very physically strong and, not have too much attrition, but that's one thing we're going to confirm because it's, in the lab scale, okay, you might find, at least I've got 10 years experience in the catalyst industry, right? You might find that it's not going to attrit away, but then you get into the real unit and it does. But we haven't seen anything yet during the commissioning, but that is one area that we're looking at is really what is the makeup rates, mainly of the sorbent. So the catalyst itself is a harder material, so we do not expect that to attrit away. Sure.
So transferring the sorbent back and forth, are you using CO2 or hydrogen as the carrier?
So it's the process gas.
Just the process.
Yeah, the process gas going through there. Okay. Well, thank you very much. And if you have any questions, feel free. I'll be right over here after this, or feel free to reach out to any SLB contact. Thank you.